All right, we are going to look at days 1 and 2 examples. You should read the information on pages 2 and 3 to go over all of the vocabulary before you try these examples. Okay, example 1 is asking us to describe this set of Monday, Tuesday, Wednesday, Thursday, Friday in 3 ways. The word description is just saying what it is in words. It's the set of the day of weekdays, not including the weekend. That's one way you could word it. In roster form means I'm listing them out, so I literally list out the days. I just used abbreviations. Set builder notation, it says X bar X, which means X such that the set of all X such that X is, and then a description, a weekday. Okay. Then you're going to make sure you read all of these examples in vocabulary words, and we're going to look at examples number 2. Find the cardinality of each set. So the cardinality, like the definition said here, just means how many are in the set. So this set has 2 items or 2 elements. This set, if I counted from 1 to 31, would be 31 elements, but I'm leaving out 1 and 2, so that's 29. These dots here just mean the pattern is continuing. So I'm continuing to count by 1 from 7 until I get to 31. For this problem, I originally wrote 4 as the cardinality, but you cannot count something when it's duplicated. So this is only 3. So since there are 2 identical items or elements, we don't count them twice. Okay, example 3 says, are sets A and B equivalent? If we look up here at our definition, it says they have the same number of elements. Okay, so are they equivalent? A has 1, 2, 3, 4 elements. B has 1, 2, 3, 4 elements. So yes, and we could use the notation A is equivalent to B. Example 4 says state whether the following pairs of sets are equal, equivalent, both, or neither. So again, if we look at our definition, equal means they have the exact same elements. So the first one, 1, 2, 3, 4, 5 elements. 1, 2, 3, 4, 5 elements. They have the same number of elements, so they are equivalent. Okay. They are not equal because these elements are not the same things. So not equal. Okay, the next one, we've got 1, 2, 3 elements. And this one, the next set has 1, 2, 3, 4. So these are not equal and not equivalent. So it would be neither. The second one, we have 2 elements in both, and the 2 elements are identical. So these are equal. So we could say A equals B. Right, so that's example 4. We're going to go on to the practice page next. So for our practice page, it says convert each set, state the cardinality of each set. So it says write the set builder notation form for the set of odd numbers less than 10. So odd numbers less than 10. So X such that X is an element of the odd numbers and X is less than 10. You could write it like that. This symbol just means element. Write the roster form, so that means make a list for the set of even numbers between 9 and 21. So when I'm making a list, the first even number would be 10, 12, and I'm just going to count by 2s and list all my even numbers. I'm going to stop at 20 because it said it had to be between 9 and 21. Write a word description for the following set. So what's happening here? I'm counting by 5s. I start at 5 and I end at 30. So we can say it's the multiples of 5 between 5 and 30. And I'm going to say inclusive. Inclusive means I include 5 and I include 30. Write a word description for the following set. This says x such that x is an element of z. So what does z mean? Z means integers. Okay, this is in our vocabulary. So x such that x is an integer and x is greater than 8. So we're going to say that this is integers that are greater than 8. Write the roster form. So roster means make a list for the following set. X such that x is an element of n. So we look at our list and see what n means. N is natural numbers. These are our counting numbers. We start at 1 and we count. So no decimals, no fractions. Okay. X is greater than 5 and less than 12. So we're going to say these are our natural numbers between 5 and 12. That's one way I could say it. I wouldn't say inclusive because it's not 5 and it's not 12 because there's no equal to bars. I could have also said natural numbers greater than 5 but less than 12. So natural numbers that's another way to word it. All right, number 2, are the following sets equal, equivalent, or neither? So remember, equal means they are exactly the same. Equivalent means they have the same number of elements. So set C has 4 elements. Set D has 4 elements. So they're definitely equivalent. So we could say C is equivalent to D. If I look closely, I can see that they have the exact same elements. So they're equal. They're just listed in a different order. All right, next one. C has 4 elements. D has 4 elements. But the elements are not the same. So they're only equivalent. They're not equal. Cow, sheep, bird. There's 3. CSBF. There's 4. So this is going to be neither. Not equivalent. And they're not the same. Number 3, show that the sets green, blue, yellow, red, and square, triangle, circle, hexagon are equivalent. So how would I show that they're equivalent? We would talk about their cardinality. They both have a cardinality of 4. There's 4 elements in each set.